Okay, in this video I will show you how to build a diving computer using a microcontroller. If we look for diving computer in Google, we see this list, like 500 euro, something like that. 560 euro are like 600 something dollars. And these computers are used to dive in a safe way because they compute the dissolved nitrogen in your body, so they tell you when you can go up or when you need to do a decompression safety stop in order to release the nitrogen without creating bubbles and injuring yourself. Why this is needed? Because the nitrogen is in an equilibrium in the pressure of your medium inside your body, so when you dive deep, like this is a plot in which the vertical axis is the pressure, here is the atmospheric pressure, 1 bar. When you go down to 7 bar, which means 60 meter depth, the nitrogen tries to equilibrate, and those are the colorful curves, are the dissolved nitrogen in the body, and the more reddish are the ones in the tissues that diffuse the nitrogen more fast, like the surface of the skin or the blood. And then you have the purple here, in which are the parts of the body where nitrogen can reach with more difficulty, like the fat or maybe the inside of some other organs. And then you see, you go deep, you stay at this depth, and progressively the different parts of your body saturate with nitrogen at different velocities. Then you start to go up again, you decrease the pressure, and eventually the situation will be reversed. Some parts of your body have a higher equilibrium pressure than the one you are, so you are releasing nitrogen, and you need to do this in a slow way. That's why you have this scale here, in which you don't create too many bubbles that can injure yourself. So what I propose to do is to use an analog computer to solve this equation instead of using numerical methods. So I propose to use an RC integrator, which is this figure here. We have the voltage in, voltage out, and we have in series a resistor and a capacitor. The voltage out is in two sides of the capacitor. Why I use this circuit? Because it's very convenient, because it follows the same equation as the diffusion of a liquid or the diffusion of a solute in a material, like these curves. So we see that the current is equal to a constant times the derivative of voltage with respect to time, but actually if we change the physical meaning of this, instead of voltage we use nitrogen concentration, and this constant is the diffusion coefficient of nitrogen in the human body or in the different organs. We can use this to know this diving equation. Why is this called RC integrator? Because under some circumstances this gives you the integral of the input voltage, but this is only in case where the input voltage is a pulse with a very short duration, much shorter than the characteristic time of our system. So this is not relevant for us now. It doesn't work as an integration. How do I propose to implement this? I propose to use a microcontroller. This is not an Arduino, but for the ones who know Arduino, it follows the same principle, and actually it's programmed using the same language and the same interface. This is an STM32, so the difference between this and an Arduino is that this is a 32-bit processor, not an 8-bit like an Arduino. It's much faster, it runs at 72 MHz, and the analog digital converters have 2 more bits of resolution. So if we look at an Arduino, which the analog pins have I think it's 10 bit of resolution, 2 exponent 10, it's 1024 values that we can turn from analog into digital. So if we get an analog sign, we can divide it in a precision of 1024 divisions. While in the STM32 we get 4 times more this, so we get 4096 values. So this is a very convenient property. And apart from this, the difference with an Arduino Nano or Uno is that this doesn't have an integrated serial to USB converter in the board. It means the first time we need a serial converter in order to communicate with it. So this is the item if you want to buy from AliExpress. It's just 1.25 euro, which is like half of an Arduino Nano. And the serial converters that you need to use, unless you already have an Arduino, you can use the Arduino as a serial adapter between the computer and the STM32. I have this one here, the PL2303, which is not very convenient because the latest drivers for this doesn't work anymore for this chip. So you need to look for the good ones in the internet. I propose that if you get one, you get something with a CH340 chip, which is the same chip of the serial adapter of the Arduino. So if the Arduino works, these ones will work. And also make sure that the logic levels are 3.3 volts. You will find adapters with 5 or 3.3. 5 volts will probably damage the the STM32, so you need to make sure that the TX and RX pins run at 3.3 volts. Okay, so we go to the code. Actually, it's a very simple code. I will go back to the RC to explain you how the wiring is made. I have this circuit with a resistor of 10 kilo ohms plus a capacitor of 470 microfarads connected in series, and I have this and this connected to analog inputs. So I can measure the I have the voltage in and the capacitor, the central point, to connect it to digital inputs, to analog inputs, and this is the ground and this is the plus 3.3 volts. So I can measure the voltage in the V in and the voltage in the V out. The code is really short, so I don't even need to scroll. We see I define the PA2 and PA0 input pins. So the PA2 will be the voltage in the sensor. I call it sensor, it's the input voltage, and the int pin for integration pin, it's the out voltage. So the only thing I do is to read these voltages and output them in a serial. You see here serial begin at about rate of 115200, and here you have the printings with in value and integrated value. So I upload this to the board, and we can go to check the serial plotter. So as I told you, you see this value here, it's 4096 minus 1. It's the number of divisions after passing an analog signal through the analog to digital converter of the STM32. Now I will move the trim pot, and you see I will put it at 1000 because it's convenient for this, for the case we are sitting now. So the blue line is the value of the V in that I'm controlling with a trim pot with my hands, and the red value is the value in the capacitor, so it's the V out. So in the diving problem, what is this? The blue line will be the pressure at which we are now, and the red line will be the equilibrium pressure of nitrogen dissolved in our body. I will go up and down again to avoid the output changing the scale. So for the values, the vertical scale is the pressure. Let's say 1000 is 1000 millibar. Actually, this doesn't have physical units, but it's convenient to say like so. So this atmospheric pressure is at the surface of the water, and the 4000 is at 4000 millibar of pressure, which means it's at 30 meter depth. So what happens when we dive? we go deep, we go to 30-meter depth, and we see that the nitrogen concentration tries to catch up, and then let's say we stop the dive, we start going up, and we start degassing our body, the nitrogen starts going out, we make some security stops, and the nitrogen keeps going out. If we just stay at this depth, which is like 8-meter depth, we will reach equilibrium, and then we go to the surface and the nitrogen keeps going to reach the equilibrium. So how can this be used for diving? Let me again go up and down to keep the scale. What we need to do to adjust these values for a real case is to increase the resistance or to increase the capacitor in order to have the same characteristic time as the real time. Or if we don't really want to use while diving in real time, we only want to simulate a dive. For instance, this time we can say it's accelerated 100 times. Let's simulate a diving. We go deep to 40 meters, we stay 5 minutes, we go up to 15 meters, we stay 10 minutes, and then we keep going up, decompressing, we make a security stop, and we go to the surface. And the difference between the red and blue line will be the difference between the equilibrium pressure and the actual pressure of nitrogen in our body. So we should not surpass some values, because if the difference is too big, it's when the nitrogen will create bubbles in our body. Let's simulate now that we go to 40 meters depth, 30 meters depth, so 4000 millibar. We stay there like for half an hour, and then we just go up without following some decompression, and this is the surface. So you see that the difference between the blue and red line is much bigger than the cases before where we make some stops. So this is the potential danger of the compression accidents in diving. Okay, I hope you like this video and you try to implement it with your Arduino or STM32, and you keep trying some other experiments with other computers. Bye!